Electrical safety, it's not just good to know, it's vital. Electricity powers everything around us, but it demands serious respect and careful handling. Neglecting the basics can lead to severe injuries or even fatal accidents. Understanding how electricity works, its hazards, and the safety protocols isn't just good to know, it's essential for everyone who encounters electrical equipment. Electricity flows through circuits, and materials like metal are conductors, allowing the flow easily. On the other hand, insulators like rubber and plastic resist the flow, which is why they're used in safety measures. Grounding provides a safe path for electricity to travel if there's a fault, diverting it away from people. Understanding these basic concepts helps you grasp the potential dangers. Electrical hazards go beyond just shock. Arc flash is a sudden, violent burst of electrical energy, like a mini explosion of plasma, causing extreme heat and blinding light, leading to severe burns. Arc blast is the concussive force from that flash, which can throw people physically. Electric shock depends on the current and duration, and even low currents can be fatal if they flow long enough. Burns can be internal from current passing through tissue or external from the intense heat of an arc flash. Electrical fires can happen from faults in wiring, short circuits, or overloaded circuits, especially near flammable materials. The core safety strategy is to recognize, evaluate, and control potential hazards. First, recognize hazards by actively scanning your environment and understanding dangerous situations. Then, evaluate the risk by assessing the potential impact and urgency. Finally, control the hazards by putting in measures in place, like fixing freight cords or creating a safe work environment. De-energizing equipment, or lockout/tagout, is the most fundamental safety measure. Always turn off the power before working on equipment, especially if it's 50 volts or more. Working with live electricity is extremely rare and should only be done in specific conditions. The lockout/tagout procedure ensures equipment stays de-energized, involving steps like preparing, shutting down, isolating, applying locks and tags, releasing stored energy, and verifying no voltage exists. Locks physically stop accidental re-energization, while tags provide warnings. For complex situations, a specific written plan and one designated person in charge are essential. Grounding provides a safe path for fault current, and temporary protective grounds protect workers from accidental re-energization. Overcurrent protection devices, like ground fault circuit interrupters or GFCIs, detect leaking current and shut power off quickly, especially near water. Physical protection, like insulating materials and barriers, keep people away from live parts, and maintaining safe distances from power lines is crucial. Temporary power setups, especially on construction sites, need careful consideration due to exposure and the risk of fire. Always locate and mark buried electrical lines before digging. Planning and communication are vital, including job safety plans and job briefings to ensure everyone understands hazards and safety measures. Proper tool use is crucial, using insulated tools, inspecting them for damage, and ensuring they're appropriate for the voltage. Avoid using standard electrical equipment in wet or hazardous conditions, and be mindful of battery hazards, like arc flash and chemical risks. Personal protective equipment is the last line of defense. Arc-rated clothing resists flames and insulates from arc flash heat. Other protective gear includes hard hats and voltage-rated gloves. In case of an electric shock, never touch the victim directly if they're still in contact with power. Your immediate priority is to cut the power source. Only trained personnel should attempt to rescue someone from a live source. Once the victim is clear and the power is off, assess their condition and seek immediate medical attention. Training in safe rescue methods, first aid, CPR, and AED use is crucial. For electrical fires, never use water. Use a Class C extinguisher instead. Beyond rules, developing a respect for electricity is essential. Continuously apply the recognize, evaluate, control model. Prioritize de-energizing,